If you could please find your notes for the probability unit. These will be on the back of the counting combinations and permutations notes. And we're going to begin in the first column with probability 1. We're going to begin with several definitions. The first is sample space. That is the collection of all possible outcomes of a chance experiment. So for example, if I were going to roll a die, then my possible outcomes would be either I'd roll a 1, a 2, a 3, a 4, a 5, or a 6. So this represents all of the things that I might roll if I were to roll that die. The event is the collection of outcomes from that space. So if I was rolling the die, my event might be, what if I rolled a prime number? And those are the prime numbers out of the list that I had for the sample space. Or if I rolled a prime number or an even number, that would include all of these outcomes. Notice that 2 is both prime and even, but I didn't list it twice. It's only listed one time. Next definition is complement. That consists of all the outcomes that are not in the event. So let's say I wanted the event of not rolling an even number. It's denoted by E to the C in the superscript for complement, and it's equal to the 1, the 3, or the 5. You might also see this written as not something. Like in this case, it might be not even. This little tilde mark stands for not. All right, next we have the union. That's the event that A or B is happening. And that consists of all the outcomes that are in at least one of the two events. So it can be an A or it can be in B. So rolling a prime number or an even number, which we've already spoken of, would be an example of a union. And generally it's denoted with this little U, the event that A is union with B, event A being prime, event B being the even number. Next is the intersection. That's the event A and B happening, and it consists of all outcomes that are in both events. So for instance, if I wanted the event of drawing a red card and a 2, it would have to be red and 2 at the same time. So for instance, I have a 2 of hearts in a deck of cards, and I have a 2 of diamonds, and those are the only possibilities in that deck of cards. And it's generally denoted by the upside down U for intersection. All right, next is mutually exclusive. This is also referred to as disjoint. And two events are mutually exclusive or disjoint if they have no outcomes in common. So no outcomes in common. So an example of something that couldn't happen or didn't have anything in common would be in my dice example. If I roll a die and I want to roll a number greater than 5 and be odd, that can't happen at the same time because the only number on a die that's greater than 5 is 6, which is not odd. Another example might be that the probability of a person being 35 and a senior citizen. That can't happen at the same time. So those are a couple examples for you. All right, next is Venn diagrams. And those are used to display relationships between events. And sometimes it's helpful to draw a diagram when you're trying to figure out probabilities and see if events have things in common or if they're disjoint. And so we're going to just kind of refresh our memory on Venn diagrams here. All right, this diagram represents the complement of A. In the colored orange section is everything that is not in the set A, which is the complement. This diagram represents A or B. So it's all everything in A and everything in B. They can be in one or the other. Here's A and B. Has to be everything in common in this middle section. Have to be in both of them. And here would be two events that are mutually exclusive or disjoint. Notice that they do not intersect and don't have anything in common because they cannot happen at the same time. Now you have some other Venn diagrams on the bottom of your notes. We'll be talking about those in class. But we're going to move on to probability notes 2, which is on the right-hand side of your paper. Alright, your first definition on this part is probability. Generally, it's denoted by the probability, and in parentheses we'll have the event. So if I want the probability of rolling a 2, I would have probability maybe of just a 2 inside the parentheses. And generally that's the favorable outcomes divided by the total outcomes. And it's important to note that this method for calculating probabilities is only appropriate when the outcomes of the sample space are equally likely. So like if I'm rolling a die, I have an equal chance of getting any number because there's one number on each side of the die. Experimental probability, that's the relative frequency. Remember, relative frequency is a percentage at which a chance experiment occurs. So for example, if I flip a fair coin 30 times and I get 17 heads, and I want the probability that I got heads. So the probability that I got heads is 17 out of 30. And then I would reduce that if possible. And a lot of times we report probabilities in decimal form. Alright, next, the law of large numbers states that as the more repetitions that I do of an experiment, so the more times I flip a coin, the closer that the difference between the relative frequency of an occurrence for the event and the true probability approach 0. So the true probability of flipping a coin and landing on heads is 1/2. But if I only did it 30 times, I didn't quite get 1/2. I got 17 out of 30. Well, if I did it multiple more times, I would get closer and closer and closer to the true probability of 1/2. And that's what the law of large numbers means. Alright, now we're going to talk about the first four rules of probability. I know that we skipped over the word independent in your notes, and that's okay. We'll talk about that at another time. So rule number 1, they have to be legitimate values. So for any event E, your probability of that event must be between 0 and 1. So it can't be negative, and it can't be greater than 1. It can be equal to 0, because you can have a 0% chance of something occurring, and it can be equal to 1, because you can have a 100% chance of something occurring. Rule 2, your sample space. If S is the sample space, then the probability of S is equal to 1. And it's also important to note here that all probabilities for a certain event must add up to 1. So if I had the probability of rolling a 2, and I actually got 0.4 on that, and then the probability of rolling a 3, and I got 0.2 on that, that's 0.6. So the other probabilities of the numbers would have to be 0.4, because 0.6 plus 0.4 is equal to 1. So all your probabilities must equal 1 for your total sample space. And here, your complement, for any event, the probability of that event plus the probability that that event does not occur is equal to 1. And I also told you, remember, that this could be written, the probability of not could be written as the probability of not E, and that's a lot of times the way I write it. Also, sometimes people write it with E to the superscript C, the probability. But generally, for our purposes, most oftentimes I will use this abbreviated form. The last rule for today is the rule of addition. If two events are disjoint, meaning that they have nothing in common, they cannot occur at the same time, then all we have to do is simply add those two probabilities together. And the word or, in general, will point you to this addition rule. So if you see the word or, that should point you to addition. Now, if two events can occur at the same time, you have to add their probabilities, just like you would for the one up here, but then subtract off the possibility that they happen at the same time. Okay? And so that concludes this video, but I do need you to turn the page. You should see some example problems, and I would like for you to do example 1 and example 2 and bring those to class tomorrow. And I'll see you then.